Well, hello friends. Welcome back to the program. Today we're going to work on the Ladybird browser, which is the cross-platform version of the Serenity OS browser that I started working on a while back. And here it is running on Linux with the libweb and libjs engine from Serenity OS browser. And one of the big architectural issues with Ladybird at the moment is the fact that it has to deal with two event loops and two event loop implementations. So we have the Serenity event loop, which libweb uses. That's the libcore event loop stuff. And we also have the Qt event loop, which comes from Qt application. And I'll show you how that gets set up. So in the main function for Ladybird, we create a core event loop and also a Qt application. And then what we do is we make a repeating timer that wakes up every 50 milliseconds and then processes any pending events in the Qt event loop. And then we let the Serenity core event loop drive the program. And the result of this is that you have this 50 millisecond lag or latency that's very noticeable when you're like scrolling up and down the menu because the cursor kind of lags behind. And it's also slowing down loads, resizing. Any kind of interactive stuff is less responsive because of that 50 millisecond latency. And I think page loads are probably slowed down quite badly as well because we also drive network requests through the Qt network access manager system. And when it's like trying to signal itself internally, then there's also that 50 millisecond wait before we process queued up events and stuff. So this thing is definitely like ruining performance on Linux or Mac or wherever you're running Ladybird. So today we're going to get rid of it. And the idea I have here is that we're going to make it so that you only need the Qt event loop, and then we will teach libweb how to deal with sort of an arbitrary external event loop. And we're going to do that using kind of a plugin. So Ladybird will inject a plugin into libweb, and on Serenity OS, the browser there will inject its plugin into libweb. And it's just going to be a basic like abstract virtual class that has some virtual functions that know how to create the event loop, spawn a timer, stuff like that. And then we can implement those things in a platform-specific way in the respective browsers. And libweb just will have some kind of abstraction so that it can talk to these things through a virtual interface. So it's kind of already how the network requests work. If we look at initialize web engine, you will see that we set up these managers here or whatever. So resource loader, for example, we initialize the libweb resource loader with a request manager Qt, which is then an implementation of the abstract interface resource loader connector. And this is what libweb will talk to in order to do stuff like DNS prefetch, pre-connections, and also starting network requests. So because they go out through this thing, we are then able to implement that in Ladybird to do what we do here, I guess, which is to create a Qt network reply or a Qt network request via the network access manager. Anyway, all that to say, let's do something similar for event loop stuff. But I think the implementation of these platform-specific strategies or policies or managers or whatever so far, it works. But I think I would like it if they were like a bit more centralized. So imagine we would have something like platform, like a libweb platform namespace where we keep all the platform specific things. And then here we would say something like install event loop plugin or something like that. And then we would install a plugin that then handles the stuff. So event loop plugin Qt create, maybe something like this. And let's go ahead and create some files so that we can actually implement this class, and then we have to figure out how it works, what it does, and so on. So let's see, we'll put it in libraries, libweb, platform. Okay. And then let's have event loop plugin .h. Okay. Oh, my insert copyright thing is not working. Well, no big deal. So let's figure out what an event loop plugin looks like. Public. So it definitely has a virtual destructor, and then it needs a pure virtual something. I think the main thing that we do, with the event loop in libweb is we have this operation called spin until, which essentially it will just keep spinning the event loop until a certain condition has been met, and the condition expressed via this function object. So you pass in a function object, we call that function object over and over until it returns true, and then we return from spin until. And spin until is used in places, like in lots of places. For example, in the HTML parser, and it actually, we have HTML event loop, I guess, which does some HTML specific stuff around spinning. But yeah, down here is the actual core event loop stuff in libweb. So now we cannot do this anymore. We can't just use core event loop. So we're gonna have to use our platform event loop plugin instead. Also, this code looks kind of weird. If goal condition, return true, otherwise return goal condition. Okay. I feel like that could have just been move goal condition. Anyway, so here we're gonna say platform event loop plugin, something like that. Maybe event loop plugin yes, there we go. Okay, and then the web platform event loop plugin, sure. So the event loop plugin needs to have spin until. Spin until. So condition, let's say, spin until condition, or goal condition, I think was the name we used elsewhere. And we'll say that's a pure virtual, so you have to implement it. And we will also make one of these things so that you can get to it once it's been installed. And what did I do? I feel like I used like a free function or something. Initialize web. Yeah, it's okay. So let's do something like this instead. Event loop plugin install. Yeah. Platform event loop plugin. All right. And event loop plugin Qt. I guess we could put that in a separate file. Let's see. Event loop plugin Qt. Okay. And then static void install event loop plugin. So something like this. Do we need reference counting for this? Not really. Maybe we just let the caller be responsible for ownership. It's going to be permanently around anyway. So let's see. That seems okay. Yeah, and then event loop plugin cute. Okay, so how would... Oh, now I can do copyright inserts. That's weird. Okay, so here we are in Ladybird. And in Ladybird, we are going to include libweb, a platform, event loop plugin. So we're going to make one of these things, event loop plugin cute. Web platform event loop plugin, sure. And you get a virtual destructor, of course, and you'll also get spin until. Not void though. Yeah, there we go. Goal condition, override. And unimplemented pure virtual. Wait, what? Oh, maybe I need to, there we go. Okay. Oh, and then we also need a create function. Event loop plugin cute. Well, maybe that's overkill. Let's make it simple for now. Because these things, you know, you don't need multiple ownership of these things. I think. Don't have to overthink it. Okay. All right. So what goes into this thing? Oh, did I need to say Ladybird here maybe? Seems like I did. Okay. Wait, what? Cannot cast it to its private base class. Oh. Missing a public keyword? Sure. All right, so how do we implement this? Event loop. Destructor, easy. Spin until, less easy. So I think we need to tell the Q core application. I should know this. I mean, I haven't been working with Qt for a long time, but I feel like I kind of remember how to do this. So while not goal condition, Q core application process events, right? Right? Yeah. That's cool. And okay. Let's see. I need to edit the CMake list here. So to make sure that we actually compile the event loop plugin Qt. Okay, and then we need to also we need to make a CPP file in libweb for event loop plugin. And here we need to implement the destructor. Okay. And also these two fellas. So nothing fancy here. We'll just yeah, we'll just make one of these things here. Something like that, and then we'll also verify that that you don't have one already. So verify not as the. Okay. Cool. Does this build? So spin until is one thing that we do, but another thing we also do is timers. So timers, currently in libweb, there's all these libcore timers everywhere, and they just kind of implicitly attach themselves to the current core event loop, and they don't know anything about Qt. So we also need to abstract out timers and make some kind of platform independent timer thing. But we'll figure that out. Let's see. Oh, right. In Ladybird, I need to do this little thing to get it to play out nice with having Qt and ACK in the same place. Okay, now we're just missing the destructor for event loop plugin Qt. No. Oh, the constructor. The constructor is missing. Okay. Hey, it builds. Okay. So I have a feeling that it's no longer going to load Google. Oh, okay, it still does. Oh, wait, because did I actually not use it? Maybe it doesn't. Let's see. Serenity, userland, libraries, libweb. We need to look for core event loop. Okay, so there isn't any core event loop. That's good. But I bet you there's timers. And also we still have the, in our main function, we still create the core event loop. So let's just get rid of that actually. And then run the Qt event loop only. And get rid of this goofy repeating timer driver so that we are forced to make everything work here. So let's see, core event loop, bye-bye. Browser window takes a core event loop, no more. Can't store that away. What did you need that for? Let's see. Why did the browser window have the core event loop? I don't remember. In close event. Oh, I see. So when you do, when you close the Ladybird browser window, then we would just force close the Serenity core event loop. But now that we're using Qt, the Qt window and Qt event loop will talk to each other somehow and figure out that, hey, we're closing the app. So we don't need that close event thing anymore, I think, at all. So that's good. Okay, so now living without, we crash. Event loop static API was called without prior event loop in it. Sure, yeah, so we are trying to do a core event loop register timer. Okay, so we need to get rid of all the core timers in the web and replace them with some kind of platform timer. So let's invent platform timer. Let's see. Oh, I already made platform. So let's invent a timer class. Hello? Can you find? There you go. Once again, copyright insertion does not work. Well, I'll just do that. namespace web platform. Okay, so what is a platform timer? Well, I think the easiest thing to do would be to just copy the core timer API, but make it all virtual, and then we can implement it by like having a virtual implementation in Ladybird that just proxies everything to a queue timer and stuff, and then it should just get picked up by the Qt event loop. So let's try to do that. And by the way, I've worked on stuff similar to this before a lot in WebKit, so I have like a decent idea of how to make these kind of things work in a web engine. But we are doing things a bit differently here compared to WebKit right now, because in WebKit, they do everything at compile time. So you compile sort of Qt specific code into your WebKit library, instead of what I'm doing now, where I'm sort of creating a virtual interface that you then plug in from the outside. And there are pros and cons to these approaches. I think you have kind of a cleaner architecture the way that I'm doing it now, but there are, we are adding a layer of indirection, right? So if you were to just put Qt specific stuff into libweb, you could reduce the indirection. But I'm not sure that it matters enough that we should put a bunch of Qt specific stuff in the web. So I would like to explore if we can keep this platform abstraction sort of clean and separated like this in a nice way. So let's try to do that at least. And later on, if it becomes sort of a bottleneck or a pain point, then we can reconsider. But let's keep it clean for now. So here we need, what do we need exactly? I guess I'm supposed to come up with a timer thing. So let's make them reference counted, because core timers are reference counted via core object. That means that we need acc_ref counted. And let's see, so we have these helper functions, the static ones. I guess we can keep those, although we don't pass a parent object anymore. That's kind of a libcore thing. But these we can keep these helpers. We just have to implement them somehow. We'll figure it out. And then all of these APIs can just become virtual. So like this, pure virtual even, let's say. Let's just say you have to implement all of these. And probably libweb doesn't even use all of these things. So it's a bit overkill, and we can probably do a better job of simplifying this. But just as a starting point, let's just do everything virtual. Let's see, virtual. All right, and all right. Oh, let's keep this though. The actual function that gets invoked when the timer fires. That one we'll just keep here as a public member. All right, and then private constructors. Oh, I wonder if they're used. Timer construct. They are used. Fantastic. Okay, so we use these, the basic one here, and the one that takes time, we also use that. Okay. So maybe we'll just do something like this, like create timer, or create, and then we can port the libweb code to do that. All right, and then all of that goes away because this is just our simple virtual interface. Okay, and then in platform timer, let's see how we do this. So what does create timer do now? Timer create. I guess we will ask the event loop plugin to make us a timer. So event loop plugin the create timer, something like that. That seems kind of reasonable. So let's give the event loop plugin a timer creating abstraction. Like that. Okay. And we need to have it forward declared somewhere. Let's put it in libweb. And are these namespaces alphabetically sorted? My goodness. All right. Well, I'm not gonna be the person who ruins the alphabetical order. So let's go ahead and put it here. Platform. And I think we just need a timer here for now. So let's put that. Okay. So given that, we can now do this. And then we had two others. So we had create repeating and we had create single shot. And we can implement them using create timer like this. So set single shot false, set interval, and timer on timeout is timeout handler, return timer. Okay, yeah, that seems very reasonable. And this one is just single shot. Okay. All right. So now we need to implement a timer cute, I guess. So timer cute. Okay, timer cute, and timer cute is going to be a subclass of platform timer. Timer cute, final public web platform timer. All right. And oh, and then we need to do all of these things actually here. So let's just copy them over. And instead of pure virtual, they are all override. Sweet. All right. So far so good. And our event loop plugin Qt also needs to have an implementation of web platform timer create timer. Okay. And that thing will return new timer Qt. Actually, yeah, we can have a helper for that. So and internally, this fella needs to have a Q timer. Maybe something like this. And I think I'm just going to forward declare it like that to keep the dependencies small. Okay. A lot of code writing here, but we're going somewhere. Timer Qt. Default, sure. And did I not define a constructor? I don't think I did. We'll do something like that. Actually, since we're newing here, let's make sure that we also delete. It's a little bit old school, but it should be okay. Okay, what does my phone want. All right. Let's see what's next. It's a message from JT, but I'm in the middle of programming now. JT, I'll get back to you. Let's see. Oh, right. I never actually declared the constructor. There we go. Okay, and then we need all of these friendly fellas. So let's see what we do with those. Timer cute. Okay, so this is where the fact that Serenity libraries are inspired by Qt, as you may know. So this is where that actually shines, or gets a chance to shine, because I think we should be able to call through on a lot of these, because the core timer API in Serenity is definitely inspired by the QTimer API in Qt. So apparently we don't have restart though. Okay, so we'll have to come back to that one in a second. mtimer stop. Set act. Oh, set act. I remember adding set active. Set active is if active, then start, otherwise stop. It's just a way of doing start or stop based on a Boolean. So is active, that goes through. mtimer is active. Yeah, forgot about camel case. Oh, camel case. It's the I used to really like camel case, but I fell out of love with it at some point. Interval. Yeah, as you can see, a lot of these, most of these just plumb right through. And finally, single shot. And then we had that one up top that we need to take care of. The restart, right? So what does that do exactly? Let's make sure that we do exactly the same thing. Okay, so restart is, restart is restart with the saved interval. So that one we can do like this, restart interval, right? But what is restart with an interval? It's if active, then stop, and then start. Okay. So if is active, stop, and then start interval. Okay. That seems okay. So let's see if we can get this thing working. So now I guess we need to get rid of all these core timers. So these become platform timer create. All right. So let's do a search and replace. Core timer construct becomes platform timer create. Kind of. You know what? Let's just do this. Core timer becomes platform timer. Boom. And core timer.h becomes platform timer.h. Web platform timer, yeah. That should work. All right. Platform timer construct. I just have to fix these up manually. So that's create, and this one. I think this is just create repeating, right? It's the cursor blink timer for a browsing context. So we blink twice per second. It's just a repeating timer. I don't know why that was doing this awkward constructor invocation. All right, let's see if we can build this thing. Seems that we cannot because what's up top? Incomplete type, non-null ref header vector in window.h. Sure, we can fix that. That's Windows CPP. Hello. Oh, here we go. Yeah, so I guess it was implicitly included through core timer. So we'll have to explicitly include it. A little bit of C++ nonsense here. Hopefully that was the only thing that was getting pulled in. Maybe not. Verify cast, not declared in the scope. All right, let's just include that. Typecasts.h. All right, common now. Okay. Let's hope that that's everything. Okay, so now we no longer have any core timer and libweb. That's pretty cool. Browsing context. Wait, what? Cross origin. Oh, did I do some bogus edit here somehow? That's supposed to say opener. Let's see. I think I'm confusing CLine a little bit with editing these files because I have the Ladybird project open, and then Ladybird uses libweb, which is in a different directory, and it doesn't have a shared, it's not under the Ladybird directory. So I'm sort of editing out of tree files as far as CLine is concerned, and I think that sort of confuses it a little bit because when I touch this line here, it doesn't get that version control indicator that this line has changed since like the master branch or whatever. So maybe I can find a way to set CLine up so that it understands that it's part of the project or whatever. I'm sure there's some way to do that. I just don't know what that is. So here is where the sources are. Or no, wait, that's not where the sources are. External sources outside project root. Oh, so everything just ends up in here? Ugh. Yeah, that's a little messy. So yeah, maybe there's a way to hook that up, and I don't know, but I'm not gonna mess with that now and turn this into a I break my CLine IDE video. But this seems promising. You know, we're building halfway through. And I'm trying to think of like what else would we need for the event loop. I guess we can look for core event loop.h in libweb, because we shouldn't need anything from these files anymore, or from that file. So if we delete all of that, let's just make sure that stuff still builds. It doesn't. Oh, deferred invoke. Interesting. I didn't think of that. Yeah, deferred invoke. We need to have an abstraction for deferred invoke as well. So deferred invoke is essentially a function that takes a callback, and then it just puts a thing on the event loop so that the callback gets invoked next time we process the event loop. So it's a deferred invocation, like run this piece of code later, right? deferred invoke, and we have a bunch of them in libweb. Okay, so these become platform event loop plugin deferred invoke, I guess. Yeah, that seems yeah, there are not many of them, so it doesn't really have to look super beautiful at this point in time. Let's see. Okay, so libweb platform event loop plugin. Let's make sure that we have okay, taking a hot minute to re-highlight the file after I changed that. And we need to add some kind of virtual for that. So deferred invoke function, just a simple void. And yeah, I would have just called that function anyway, I guess. So that seems fine. Where is our event loop plugin Qt? Oh, resource CPP, hold on. Let me make sure that. I thought I added this include, I guess I didn't. All right. And this was supposed to be timer Qt create. Event loop plugin Qt deferred invoke, blah, blah, blah. So how do we defer an invocation? Wait, why doesn't this work? Create timer. Oh, we don't have non-null ref footer. Sure. Deferred invocation, I think the easiest thing to do is probably just use a 0 timeout queue timer. So let's try doing that. They have this thing called single shot. Yes, that's the one. Single shot. And then you say 0 milliseconds, and after 0 milliseconds, I'm gonna give you ownership of this callback here, and you can just go ahead and call it. But if for whatever reason you call this thing and you pass something that is not even invocable, then let's just say you have to, right? Okay, let's take care of that before, so at least if we're going to panic because it's not invocable, we'll do it here rather than later when we won't have relevant information on the call stack. Okay, create timer is missing, or is it referenced by create timer? Okay, yeah, I'm struggling to read these linker errors. They're kind of upside down. Okay, so we needed timer Qt create, which would go in here. Non-null ref footer timer Qt create. Return a duped ref. New timer Qt. So cute. Okay, that didn't go entirely as I thought it would. Oh, I guess I'm missing a header again. Wait, why doesn't it react when I'm trying to build? Do I need to edit the CMake lists again? I do. Timer Qt. And another instance of the don't replace std stuff. Where are you? This thing right here. Hey, okay. Google, let's try it. Oh, it loads. Hey, oh, that's so cool. And oh, and the menu is now not laggy at all. That's so cool. Wow. Let's see if we can we do some tests like acid? What's the I need to look up the acid tests URL. I don't remember. Don't remember the URL by heart. Here we go. Acid 3. Let's try it. Okay. Doesn't run. Right. Oh. Because, I bet you it's because when the timer fires, the queue timer, I don't actually do anything. I'm supposed to actually fire the on timeout callback thing. So queue object connect m timer queue timer timeout. Yeah. And then I think you can just pass in lambda thingamajig. So if on timeout, boom. And then I also have to set a C locale. I'm just remembering because otherwise the JavaScript number parsing will break on ACID 3. Okay. And if we reload, 100. Hey, all right. That's pretty cool. Also, it's pretty fast. It's very nice. Let's try something fun like Wikipedia. Ooh, look at it go. Loads pretty fast. Got some layout issues here, but definitely feels more responsive than it was before. Wikipedia is still a fairly complex page, like on something like this. Oh, yeah. I don't know if it comes through in the video, but like resizing on simple content is like buttery smooth. It has not been like this before. And in fact, if we look at resizing here, like we don't get this kind of smooth resizing in Serenity. Or wait. I need to make this work on Serenity. Because I have a, let's see. Right, now I need to also make I need to make the timer thing and the event loop thing for Serenity. Forgot about those, but let's make them. So on Serenity, everything needs to go into the web content service because that's where the web content service process on Serenity is sort of the client of libweb. So I think if we look in web content main, we will find it installing these request resource loading adapter. Oh my goodness, there's so many different weird weird pattern names used, like initialize expects a connector, but we give it an adapter. This thing gets a manager adapter. It's like a whole thing. And now I'm using plugin, but I feel like these are plugins more than anything. So anyways, let's not worry about naming things right this very now, but we do need to give this thing an event loop thing. Libweb platform event loop plugin. Install. And here we will give it a what do we call this thing? We call it an event loop plugin Serenity, I guess. Okay, and that can just live here in web content. So event loop plugin serenity.h. Yes, event loop plugin serenity. We also need a timer serenity. Okay. That seems fine. Let's make sure we build those. Event loop plugin serenity. And let's be good boys and do a little sort. All right. Okay, so what's in an event loop plugin Serenity? I guess we can start with the cute one. Okay, so instead of cute, it's all about that Serenity. Still need to do the same things, but we'll do them slightly differently. So let's see. I guess we can just first do a search and replace here, say Serenity instead. Sure. And instead of Q core application and Q timer, we'll get libcore event loop and libcore timer, I was going to say, but I don't think we need that. We really just need to do, I mean, these are super straightforward, right? Because we just need to forward to the API that we've just been abstracting. Maybe that's not static, actually. Current spin until, yeah. Okay, and same thing with this one. So core deferred invoke. Yeah, there we go. And for the timers, we need to have this thing, which looks like, oh wait, no, this is the CPP file. Serenity, and we're going to use a non-null ref putter to a core timer here. And why does everything look so weird? I feel like I had a little editing mishap there. Okay. Can we salvage this? All right. I think that's going to be okay. Oh, we need non-null ref putter. All right. And then we can take timer cute CPP, slap it in here, replace these fellas. All right, now. You don't need to be here, but libcore timer needs to be here. All right, and then mtimer will do this. So core timer construct. And instead of this, we will do timer on timeout. Other than that, it's the same. Cool. We don't need the delete. Cool. I think, and here, of course, we can proxy all the calls directly to the underlying timer. So let's do that. All right. Web content main. Oh, Ladybird. That's not the right namespace. Here it's going to be web content. Yeah, so that's web content. Boom. And likewise, timer cute, but timer serenity doesn't go in Ladybird, it goes in web content. Wait, what the heck did I type? Lady web content bird. Not lady web content bird, web content. Oh, and then we need to make sure that libweb has those files. It wasn't necessary for Ladybird because when we build Ladybird and we're just globbing all the CPP files, but here we have to actually add them to the CMake lists. I don't know why we glob them, honestly, but we do. So I guess let's be alphabetical. Where's the P? All right, platform, event loop plugin, and timer. All right, let's see if we can get this thing to run on Serenity. That would be the bee's knees. Please just work right away. That would be super awesome. We're up. And can we run Acid 3? We can run Acid 3. Hey, look at that. First try. So I wanted to look at Wikipedia just to illustrate like the difference in like resizing speed. Like, look at this compared to Ladybird. Because what this really tells us is that the libweb engine is way better at resizing performance than you can actually see on Serenity, because here we're sort of held back by Windows Server being slow at resizing in general. I think part of what happens is that when we resize on Serenity, then we're like reallocating the window backing store repeatedly, which is a kind of an inefficient process. And we, I think we fault in new pages and zero them out, and we do all this, like all of this work, and we don't cache any anything, but everything has to be like reinitialized repeatedly while you're doing this. So huge amounts of space for optimization here to make resizing fast, but also there's a lot of spam. But ignoring that, it's nice to see with Ladybird that it's actually the engine is reasonably fast at resizing. It could be better, you know, like there's still a bit of slug, definitely, ignoring the layout issues. But I'm happy to see this. This is good. This is good. This is progress. All right. Cool. So this is very awesome. So what have we done here, really? We have added a platform abstraction for event loops and timers to libweb, so that you can plug in your own event loop instead of libweb always using libcore event loop. And this makes libweb that much more portable, because now it can exist in any event loop environment, basically, as long as you can implement those three primitives: timer, spin until, and deferred invoke. So really, really awesome. Really happy with this. Let's make some commits. I guess this is really like one big commit though, because everything here kind of depends on everything else. There wasn't really anything that stood out as like something we can do standalone. It all has to come in one big bundle. Yep. And then the new files here and the new files here as well. Yeah. Right. So yeah, let's commit. What don't you like? I'm missing a pragma once and timer serenity. Well, my bad. Maybe I'm missing it in timer cute as well then. I was. Look at that. libweb plus web content. Add platform or add abstraction layer for platform, for event loop, and timers. Instead of using core event loop and core timer directly, libweb now goes through a web platform abstraction layer instead. This will this will allow us to plug in Qt event loop and Qt timer over in Ladybird, fixing to avoid having multiple event loops coexisting. Having to deal with multiple event loops, let's say, yeah. Right. And I think it's also kind of it almost feels like a natural evolution of the engine to try to abstract some of the platform bits so that I would like to continue improving Ladybird, right? So in order to do that, we're going to have some patch points or like attachment points, sockets, plugin slots, whatever you want to call them, places where we can plug in platform-specific behavior into the engine. So I am happy with this. Maybe the names are not great. Maybe the specific architecture is not perfect, but the fact that we can now run on Linux without 2 event loops, without the 50 millisecond jank, that's kick-ass. So let's see. It was the same story here, right? Just like nothing really that can be separated. Everything has to come. But that's okay. So here we will say adapt to the new web platform, or install a web platform event loop plugin for, yeah. Now we can write something nicer. Let use only the Qt event loop, yeah, to speed everything up. Okay, so this patch removes the dual event loop system or setup, and leaving only the Qt event loop. We teach libweb how to drive Qt by installing a new event loop plugin. Yes. This removes the 50 millisecond latency on all UI actions, all UI interactions, and network requests, etc. Yeah, that's it. Very cool. I'm very pleased with this. Let's see, where do we want to go on the web? What's a website? Let's go to www. Why am I blanking out? Reddit.com. Let's try it out. Well, still have lots of stuff to do here, but I think this is still slow because Flexbox layout is slow, so I still see that sluggishness. Oh, let's visit the folks over at NetSurf. Wait, did I spell that right? netsurfbrowser.org. Look at that screenshot lurking under the text. Should have fixed that. This is so smooth. Oh my goodness, it's like smearing butter over the screen. I love it. No way it's this smooth on Serenity. Let's see. Oh, look at that. Not smooth. This is not smooth. But look here. Oh, this is so smooth. Oh man, that's so cool. I haven't seen LibWeb be able to go as fast as possible, I guess, before, because we've always been held back by Windows Server. And we need to fix Windows Server, obviously, make it fast. But it's just, I'm really enjoying seeing that LibWeb is more capable than I thought in terms of performance. And there's a huge amount of money on the table. Like, we can do a lot to improve performance, but this is good. This is very good. I'm very pleased, as you can probably tell. Anyway, this is going to be the end of the video. So if you made it this far, then I want to thank you for watching, for hanging out. I hope that you saw something interesting today. And look at Google. So smooth. I'm really pleased with this. And it's good to be working on Ladybird. I got a lot of ideas for ways to make it better, and more to come in that area. Thanks for hanging out. I'll see you next time.